The topic is monitoring with visualization, a three-tier Node.js Express application that is ResumeMatcher deployed on Kubernetes via Minikube. In this tutorial, I will show you strategies and steps I implemented to perform this monitoring. But before we begin, I am Kaif. I was previously a recruitment professional, now learning DevOps from zero. This is part of my transition series. If this resonates with you, stick around. So the mental model for monitoring this application is to first monitor total healthy targets, CPU, memory requests, and database connection, which is like the Postgres exporter. To perform all this, the first step was to form Minikube start with memory flag 5 GB 600 MB and CPUs of 4. I performed this command inside the root folder of my application. After Minikube was up and running, I performed Helm install monitoring Prometheus community and this command, and also created namespace monitoring, and it was successfully created with installation of Prometheus. By the way, monitoring namespace or namespace simply means we isolate an environment for a specific task. In this case, for monitoring purposes, I have isolated a namespace just for monitoring. After installing Prometheus and creating the namespace monitoring, I checked it with kubectl get pods -n, that is namespace monitoring, which shows all the required pods for monitoring with respect to Prometheus are up and running. That includes Alertmanager, operator, state metrics, node exporter, and monitoring kube Prometheus, also Grafana monitoring. After these pods were running in the namespace monitoring, I wanted to have metrics with respect to Prometheus in the path that is /metrics on the local host, or when the application would be deployed and running and I would perform /metrics. I wanted to see metrics with respect to Prometheus scraping. To do so, I first installed prom-client by npm install, so that would help in monitoring and providing that dependencies for it. Then I created ServiceMonitor.YAML, and this is a YAML file. It has a label for app ResumeMatcher and HTTP port with path that is /metrics and 30 seconds of interval. Then I updated server.js by adding ServiceMonitor and /metrics path. After this, I ran the service ResumeMatcher, that was my application, by performing Minikube service space the service name, which is ResumeMatcher service. It was exposed in the NodePort with path 127.0.0.1.59484. So as you can see, the application is running on this port. Now to check /metrics, I performed /metrics path on these ports. So metrics were visible and available, and service monitoring was successfully running to provide these results. Now for Prometheus dashboard or UI or metrics, I performed Helm repo add Ingress Nginx and created Ingress Nginx namespace to run Prometheus with Ingress. Then I created Prometheus ingress.yaml, and this Ingress is for the service name monitoring kube Prometheus, which in earlier images we saw one of the pods with this name, that was the service, and the port is 9090. And to run this Prometheus thing in my system, I had to add these inside the host, which is inside Windows System 32, inside drivers, inside etc, inside host of it. I added the port 127.0.0.1 space prometheus.local, which would mean after doing so, if I would perform http://prometheus.local, Prometheus would be up and running with that domain is specified in the host with that port. Then I performed kubectl apply -f Prometheus ingress YAML, and it successfully created that ingress. Then I checked kubectl get ingress -n namespace monitoring Prometheus ingress. It was successful with the class nginx host prometheus.local, which we specified on the port 80. Now to check the services, I performed kubectl get services svc -n namespace monitoring, and it showed me the services that were running, which includes the Prometheus service we specified, that is monitoring kube Prometheus and other as well. As we kind of created load balancer type thing by creating a domain that was prometheus.local, and we specified that inside drivers of our system, which mimics load balancer things. And to run such type of services which we have created, we must perform the command minikube tunnel, not usual port forwarding, as by default these services of type load balancer get stuck in pending because it doesn't have cloud balancer native support for load balancing. By performing minikube tunnel, it creates network route to the cluster's internal service network, that is CIDR, and it dynamically updates the service status so we can access our application directly using the local host or the assigned IP address. So simply it is because we added prometheus.local and specified that with the ports inside the host, so it mimics the load balancer. To run such type of ports and service, we must perform minikube tunnel, so we are using it. And it successfully created that tunnel. Now the prometheus.local is active. That has the host http://prometheus.local, and it shows the services that are up, that means that are running, is healthy. So that was about Prometheus, as it is successfully running. Now we have to perform Grafana for visualization of those metrics. But before we do that, we must know that we have already created service for Grafana, and it was already visible in our SVC and in the namespace monitoring. As you can see, we have specified Prometheus service monitor in the service YAML file for Prometheus metrics on path metrics, which we have seen in the local host application. So Prometheus is active on prometheus.local and as well as on /metrics path. So both of them has Prometheus metrics available. And now for Grafana, the command is kubectl port forward -n namespace monitoring service /monitoring Grafana with the ports 3000 mapped 8, and it is running. Now you might be wondering how come we have service monitoring Grafana already present while we have not created its service inside a service YAML file where we have only specified Prometheus as a service. It is because we have performed Helm install kube Prometheus tag, which means it has Grafana included by default. After it was successfully handling connection at port 3000, now it was to generate password or logging in inside the Grafana. The command for it is kubectl get secret monitoring Grafana -n namespace monitoring, and this command with base64 pipe and echo statement to give us the result of the password, which I have hidden. After this, I head back into the local host 3000 for Grafana UI or login in. I added the email or username admin and the password which was generated, and I performed the login. It was successful and I was inside the Grafana. Now to create visualization of the metrics, I went into the connections tab and clicked data sources and selected Prometheus as a source of data. After this, Grafana automatically selected the Prometheus service that was running, which was monitoring kube prometheus.monitor with the port 9090. It is simply where the Prometheus is actually running in the host or in the ports. So it automatically recognizes those ports and where the Prometheus is running, which is default. So I clicked inside it and I scrolled down and clicked test, and it was successfully queried with the Prometheus API. How it was to visualize this data by building a dashboard from scratch. To do so, I performed or I added the queries and I created the panels. For the first panel, I performed the query sum up to show total healthy targets, and for the second panel dashboard, I performed rate container CPU usage with respect to seconds total for the time 5 minutes. Second query in that same graph was container memory usage with respect to bytes. The third query in that same bar graph was rate HTTP request total in 1 minute time frame. And for the third panel or the third dashboard inside the Grafana, it was for memory usage with query container memory usage with respect to bytes request per second rate, which was HTTPS request total 1 minute time, PG stat activity count for database connections, which is Postgres. So these are the exact queries I entered, and I created these panels with these results, which I am showing you right now. So these were the results for total healthy target. It shows 14, and second is the bar graph for CPUs and everything, and it is the third for the pie chart. So that is it for the video today. If you have any questions, queries, do let me know in the comments so we can have a discussion. Thanks so much for watching. Have a great day. Bye.